you're saying if I got on that hill right there, that I might go kind of slow. So you're saying if I had to draw a line of a bunny hill here. This might be the bunny hill right here.
I knew that.
Kind of like that.
Yeah.
Okay. Well then what else? What else was there? Not the bunny hill, but what?
Like when you go up higher on the, I forget what it's called. It carries you up the mountain.
Okay.
When you go higher up, the hills get steeper. And you happen to go down them faster.
So maybe like that.
Yeah.
You're talking about ski lift there.
Yeah.
Or maybe like, if you're really good, maybe like this.
Expert level.
Is that what you're saying?
Yeah.
If you're just playing crazy, right?
No,
No, not an option. Okay, so it sounds like to me when you've been skiing before, you started out on one that's flat, and you talked. There was a word that you used there was steeper. All right. Incline. That's another word I like. That's good too. More of an incline, steeper. So really what we're going to talk about here is a lot of slope. Okay, a lot of slope. Guys, slope is basically another word for how big of a hill you have, or talking about inclination or how steep something is. Guys, which one of those, besides this last one that I just drew, which one of those would probably be the steepest hill to go down?
The third.
This third one down here. So what do you think is going to have the bigger slope value? Third one, okay. The closer I am to a horizontal line or a flat line, that's going to be like a slope of 0, and then everything else is going to change. Now, we're talking an awful lot about what's in the notes today here, guys. But your notes title, what's the title say there?
The slope of a line.
Slope of a line. So as I'm getting this opened up here, how about you guys read what our goal is for slope of a line today?
Find the intercept slopes of lines.
Find and interpret
Oh, interpret
slopes of
slopes for
a line. Okay. So we've been spending a lot of time with function form and input-output tables, and then we just looked at x and y intercepts to form our last graphs. So I think what we want to be able to do here today is look at our notes and understand what slope is, how slope is related to the lines we've been working with, and I'll wait for this document to load up. Here it comes.
Well,
Yeah, one of these days again, it looks like Mrs. Miller.
you want to send it to a printer?
That's funny because I didn't want to print it. Oh, technology.
Can I go get a drink?
Yeah.
More messages, the more problems we have.
I wore shorts today.
I wore a tank.
I know why.
I feel really cold.
You know what I don't have? A care in the world. That's what I don't have.
I know. Wow.
Oh, looks like we can't take notes today.
Oh, we'll take notes today. So slope. This one here has an undefined slope because it doesn't want to run.
I saw a line of one where this guy was sleeping and the guy goes,
There we go. Okay, so guys, taking a look at this right here again, find and interpret slope. What does slope mean as it relates to a line? So right here, what's my definition of slope?
Rise over run.
Rise over a run. Okay, rise, is that going to be a vertical distance or horizontal distance?
I know.
A rise will be a, I rise up,
Vertical.
be vertical on it. Okay, now what's a run distance going to be? Run is going to be
Horizontal.
horizontal. Okay, I think that's described up there, isn't it?
Vertical running. No, it's horizontal.
No, she
So right here, rise says it's the vertical change or the change in which variable?
Remember she takes on.
Change in y. Okay, what's it say your horizontal change is? It's a change in x. Alright. So let's start talking about slope of a line right here. What I'll have you guys do is this. It says, in example 1, we're finding a slope. Okay. It says a building's access ramp has a rise of 2 feet and a run of what? 24 feet. Find its slope. Okay, so by definition right up here, we know that the slope is a what over a what? What's it say right here?
Rise over run.
Rise over run. Okay? So if I want to find the slope in this right here, simply going to look at plugging in your rise values over your run value. Okay? So real quickly, what's the rise value again?
The rise value is 2 feet.
What's the run value?
24.
24 feet, right? So I'm going to put what over what there?
2 over 24.
Okay, so I'm going to put in 2 over 24. Now you guys may be going back to that simplification calculator at some point in your Chromebooks, but 2 over 24, what's that going to reduce to?
1 over 12.
1 over
1 over
12. Okay. Base. Grab 12 of these.
Whenever you want to say
2 would go into both of them, right?
yeah.
So your slope's going to be 1 over 12. Okay. All right. I need some volunteers up here too. Once you get 12. You get 12 of them. Here, I'll give you the last colorful one to match this group of rulers. Okay. I got some volunteers coming up here.
Me!
Come on up, Mason.
Yeah!
Mason, take 3. Terrence, take 3. Is there any way that you guys can hold them like this and this? In that one hand? And then I want you to hold the other ones in your left hand like this, pinching them. Okay. Can you do that with your other hand now? Can you hold 4 of them?
I have 3.
Got it.
Okay, now pinch with this hand. Got it? Okay, put your 2, 4, 6, 8. I need one more volunteer.
Maddie!
All right, Candace.
Oh, okay.
No.
Same thing as they are doing.
I guess you could say Maddie thought I was too mad to do.
What?
Wow, that
It makes no sense. How would you be too mad to do something? I know, but
That makes sense.
I got it.
They're in the world.
How many rulers are going side to side right here? Candace, your wings are taking off. Candace, hold these, pinch them right there. It's like Red Bull, it will give you wings.
those commercials are so dumb.
They're funny.
They're not funny.
Hey, here's a 12-foot run.
11.
12-foot run. This ramp. Imagine this ramp. This is what's going on. This is what it's talking about. Imagine this is a ramp right here. This ramp right here starts down here. What's a ramp going to do? It's going to have what's the word?
Slope.
Incline or a slope. Okay? Okay, that's my 12-foot run. Basically what it means is this. For every 12 feet I run over, I move up how much? 1 foot, right? That's what this means right here. So that's the slope. Is that a pretty flat slope or a pretty steep slope? It's pretty flat, isn't it? Okay. If I went over another 12 feet, how far in the air would this be then? Not 1 foot, but now 2 feet. Okay. It means for every 12 feet that you come over, you go up how much?
1.
1 foot. For every 12 feet you run, you go up 1 foot. Or I can say for every 1 foot I rise, there's a run up how many feet? 12 feet. 1/12. Is that slope pretty big or pretty small? Any of you guys ever shingled a roof before? Kyle, did you ever hear the word pitch?
Yeah.
Talk about a pitch.
Yeah.
Was it a steep roof or not so steep?
It wasn't really that steep.
So the
where I
pitch
was
on that
at.
was pretty low.
Yeah,
I'll get on
it
a roof.
was.
If I can walk on a roof, I'll shingle. If I get on a roof and I feel like, were you like that when you were up there?
I don't like heights, and it wasn't very high. It was my grandma's house, so it's not a very like steep.
But when you're up there, it feels like you're pretty high in the air.
Yeah,
doesn't it?
but
Yeah. Okay, thanks, guys. All right. So slope. What's your definition again, kiddos? What's your definition again? Rise over. Run. Simply put your rise in, your run in. And then what this means again, it says for every 1 unit of rise, there are 12 units of a run. Okay? All right, so let's look at a graph. What's this look like graphically? Guys, again, we've been talking an awful lot about lines, so I'm going to put a graph in here quickly. I think the first thing I'll do is pick a couple points. How about we pick a point that's 2 to the left and 2 down. So pick that point. Left 2, down 2. Guys have that point plotted?
Is the slope of a line the same with example 1?
Yeah, pretty much. And it graphically is what I really want to look at here, okay? And then secondly, let's rise up. Let's rise up 1, 2, 3, 4, and then run. Well, let me think. Go over 4 units. Go right 4 on your graph then. So 1, 2, 3. Whoops, hang on a second. Go right 4 units and up 2 and plot that point. Okay? Now, do you guys have a straight edge right now? Mason, you want to start handing those around? I'll have you guys go ahead and graph this with a straight edge.
Oh.
So everybody needs a straight edge. And this will be kind of what your line looks like.
Yellow. Pink.
Yellow.
Okay. Let's try handing this up. I'll need more help.
Okay, so I have my graph right up there. You guys do the same thing on your notes.
My lines run off.
What's that?
Pass this on to Kai.
I think
Second point's right 4 and up 2 from the origin. What was your question, Taryn?
and
I don't think my lines are straight. Oh man.
I'm not going on the hill.
I drew a warp line.
My line is straight.
How did you go up to it? Oh.
From the origin, right 4 and up 2.
Ow.
From the origin for the next point, go right 4 and up 2.
Yeah, I
I
did,
see
but it's
now.
not straight.
We'll just connect the 2 points and
Yeah,
draw a
but it
line.
won't be a straight line. It'll be a crooked line.
Oh, that'd be a crooked line.
Just
Can
draw
I
a
get
line.
Just connect the 2 dots and draw a line. Do you have what I have up there?
Something like that.
Something like it. Okay, now guys, one thing again, get in the habit of extending your graph or your line all the way across the coordinate plane. Guys, they're asking you to find the slope. One thing I would tell you about finding a slope, when you do a slope here, when they give you points like this, I'm going to make a note on this, and you might want to make this note as well. Always, always, always work from, how do you read in a book?
Right.
Left to right. So you read graphs from
Oh,
left
okay.
to what? Left to right. Okay. So you're going to read stuff from left to right. Now guys, in your book assignment today when it says find the slope, and if it says make a graph and find the slope, guess where I'm going to tell you to put your graphs at today? In the computer, right? Okay, so look at the points I'm pointing at right here. Point 1, point 2, where am I starting? Point 1, point 2, where am I going to start?
Point 1 is
Point 1 or point 2?
point 1.
Because I'm going to start on the left, right? So my suggestion to you is this. I would say, hey, start at that left point. And if slope is a definition of rise over run, start from this right here. You're going to rise up a certain number of units to get even on the horizontal and then run over. All I like to do is draw that little, whoa, didn't want to do that. Oh, didn't want to do that.
Come on, Parson.
I'm working. Computer's struggling today. I think it's important to draw the rise and the run like that. Okay, you almost form like part of a triangle on that line, don't you? So guys, here's the deal. When I did my rise from the point, did I go up or down? If you go up, is your rise going to be positive or negative?
Positive.
What would have happened if I would have started by going down?
It'd be a negative.
Be a negative. Okay, so check it out, guys. How many units did I rise up to get from point on the left to point on the right? How many units? Count your units. One. Looks like 4 of them, right? You guys agree?
Yeah.
How about the run distance? Not 7. Should be 6, right?
I'm
Okay.
sorry.
Well, that's all right.
I was talking to Maddie. She was like, come on, Mason, get program. I need to update my software.
Wow, that was
Get it? Get it? That's funny, right?
So what's your rise distance again, kiddos? Well, it's 4, right? What's your run? Okay, so 4 over 6. So, what are you going to have here, guys? What are you going to have? What's 4 over 6 going to reduce to?
2/3.
So the slope is 2/3. It means for every 2 units, yeah, simplify this stuff. It means for every 2 units you rise up, you run how many units? So for every 2 units of vertical change, there are 3 units of horizontal change. Okay? How do you feel about this so far?
Wonder.
Okay, let's jump ahead.
Wonder bar.
Let's jump ahead.
Okay, did you guys
No, mine's gonna take. I could do 7 people. When do you want our quick quiz corrections from?
Sooner than later.
Like,
No.
I didn't get my quick quiz in my,
Yeah, it's in the book, Kyle.
it is?
Yeah, Mrs. Miller can give it to you.
Alright.
Left 4 and up 2 for this next one, please. And then go right, let's go right 4. Right 1, 2.
Oh, the quick quiz is on there?
Wait, what was the first dot?
That's what you do out of the book.
Alright, I'm
Left 4.
had a rough week.
Left 4 and up 2, and the other point will be right 4 and down 2 from the origin. Go ahead and draw that line.
Hang on. Over 2,
So the first one, first point, you go left 4 up 2 units.
left 4.
Mm-hmm.
Make sure. Arson.
Could we left 4 down up to right 4 down?
Yeah.
We good, because that's how it is.
Oh, I forgot to sign up for parfait.
We have till 10.
Yeah. We're going to the lunch today, guys.
Who says I want to even know with you? I'm just
I
kidding.
did.
Can I get my money? I'm just kidding.
And how many? We're supposed to go 4 left.
In like
4
2
left
in
and
like
up
3
2.
years.
That's the first point. 4 right down 2, second point.
I just put my case on wrong.
Okay, guys got that line drawn?
Sure.
Okay. See, Aptitude talks about this idea of finding positive and
Negatives.
negative slope. Okay? Finding positive and negative slope. And it says find the slope of the line shown. Now again, how do we work in these from what to what?
Left to right.
Left to right. So I want to start with the point on the left and I want to move right. So guys, you agree that this is my starting point right here?
No.
Okay, so if this is my starting point right here, talk to me about my rise. Will I be moving up from this point or down from this point?
Down.
And as I move down and make this L shape to get to that point, as I make that L shape to get to that point, talk to me about that rise. If I start by moving downwards and then over, what kind of a rise is that in terms of, yeah, it's going to be a negative rise, okay? So talk to me about this distance and moving downwards. How much is that, or how many units? Isn't it 4 units down?
Yes.
So I would attach a negative 4 for the rise, wouldn't I? How about your run distance? How far to the right do you run?
You don't run period.
4, 5, 6, 7, 8. 8.
As a track coach, I don't like that. Okay?
Oh my god. Me and Mariah were on the bus yesterday and we were like, maybe let's go for a walk. We just started laughing.
Okay? Negative 4 over 8. So your slope's negative 4 over 8. So guys, what I want to get at here is this. slope would equal negative 4 over 8. Guys, think of this line. I've told you to work left to right the whole time. If you were working left to right, would that be a downhill line or an uphill line?
Downhill.
It'd be downhill. And downhill lines are going to have what we call a negative slope. Do you guys agree this will simplify to negative 1/2? Okay, it means for every 1 unit we come down, we run to the right 2 units. Alright? So if you can think left to right, look at this right here. Left to right, downhill or uphill? Downhill will be what kind of a slope? Negative. If I go back to the first page here and say, look at this line, uphill or downhill as they move left to right? What kind of slope did you have here, positive or negative? So an uphill line, positive slope, a downhill line will represent negative slope as you look at it from left to right. Okay? Alright, I've got a good one for you. How about this? Here's your 2 points. Let's go left 4 and up 2.
Left 4.
And let's go right 2 and up 2 and plot those 2 points. Alright? I like this one. You know what? I shouldn't put this in here, but we already talked about positive slope. Hang on a second. But I'm going to do it anyway. I'm going to do it anyway. What the heck? Here we go. Draw your line through there. Okay. Left to right, guys. Left to right. What's your rise? There is no rise. It's 0, isn't it? How about your run distance?
0.
How far do you run?
Oh.
Don't you run 6?
Yeah.
Okay, so a rise is 0. What's your run? Is it your run 6? Okay, so your slope would be 0 divided by 6. Is this uphill or downhill? Or neither? Neither. Okay, it's not moving uphill, it's not moving downhill. Alright, so if that's the case, we transition basically, watch this right here. What kind of a slope is my arm at?
Like a high V.
Well, positive or negative?
Positive.
What's it at now? If I'm going from positive values down to a negative like this, eventually what value do you have to pass through?
T.
0. You got to pass through 0 to go from a positive to negative. Isn't 0 the separation between positives and negatives? So anything that would be flat like that or horizontal is going to have a slope of what? What value what's 0 divided by 6 going to be?
0.
0. Okay. Guys okay with that? Alright. Well, I think we've got slope down, rise over run. So what we want to start looking at now is this. How do you find slope when there is no graph? I just say, hey, here's a couple of points. Here's how you're going to find your slope. Okay. First of all, guys, how many points have I given you on all of these? 2 points, right? Well, I was giving you 2 points. Okay? And those 2 points have coordinates. Alright? Here's the deal. Basically, this is like point 1. This is like point 2 in the example we're going to look at. Alright? Now, I'm going to put a formula up here. And this formula is going to look kind of goofy. But I think if you listen to what I say here, you're going to understand what it says. It says finding what, guys?
Find slopes
Without graphs. Okay, for whatever reason, and I'm not really sure I understand this, they use the variable m to represent slope. Okay? So when you see an m anywhere, you always say that m in this section is going to represent my slope. Okay? And here's the formula for it. What it says is it says slope is equal to your y2 value minus your y1 value over your x2 value minus your x1 value. So you want to make sure you've got that down as I have it up there.
Oh,
y2 minus y1 over x2 minus x1.
remember some of this from last year.
I don't remember anything from
The
last year.
like the y2, y1, x2.
All right, here's the deal.
There's also an x3.
This is your first point, right, guys? 2, -2 that they give you?
Yeah.
Okay, now keep in mind, all points are x comma what?
1.
Okay, and this is your second point right here, 0, 4. Keep in mind, all points are x comma y. What this formula is telling you is this. You're going to take the second point, take the y value. So what's the second point? Well, it's down here. What's the y value in the second point?
4.
So in this example, to find a slope between 2 points, when you're not given a graph, simply do this. Plug in numbers. Second point, y value, what is it? 4. Minus, okay? This says go to the first point. Plug in the y value. Well, first point, y value, what is it? -2. So 4 minus what value here? Okay. With me there? All right. So how about the bottom then? So go to the second point again and plug in the x value.
Okay.
0 minus my x1. So 0.1 x value. What value is the 0.1 x value? Okay, you understand how I've taken these values from those 2 points and plugged it in from the formula. All right, help me out then. We've got some calculating to do. Guys, when you subtract a negative, this is really what operation? Addition of the opposite, right? So it's like adding, isn't it? Okay, so what's 4 minus -2? It's like 4 plus 2, isn't it? 6. What was 0 minus 2 in the denominator?
2.
What kind of 2?
-2.
Okay. Now, it turns out that -2 actually divides evenly into 6. If I wanted to simplify this right here, what's 6 over -2 when I simplify to? Or what is 6 divided by -2? What kind of 3? -3. Okay. -3.
Whose Keurig cups are those?
Mrs. Miller, can I ask you what the points are if I plug this in? If I've done this correctly, by the way, is this going to be an uphill graph or a downhill graph?
Uphill.
Downhill.
Downhill.
Downhill because the slope is negative right there.
Karen, you're so wrong.
What are the 2 points again, Mrs. Miller?
2, -2.
So if I go in here, plug in my points.
Don't you know that? I'm Einstein's cousin.
2, -2, you say, Mrs. Miller?
2, -2, and 0.
0, 4. All right, so I'm going to plug my points in. We've done this, haven't we? Have you seen me plug points in here?
Has a dream.
Remember when we were doing function form and plugging points in?
And 0.
By not using them.
Hey, check this out here, kiddos.
Wait, thought you said though.
I can also make sure I'm doing this correctly this way if I wanted to come in here and plot points and watch what happens here. It's pretty nifty.
Nifty.
Oh yeah. It's pretty nifty. If I say, hey, check it out. Those are the 2 points that we were talking about, right? What do we get for a slope between them? -3. Okay. Check this out. What's your rise working left to right? How far down? What kind of 6?
6C.
What kind of
It
6?
is 6C.
What's your run?
2.
Guys, what's -6 divided by 2? -3 again, isn't it? So if I look at it graphically that way, it works as well, doesn't it? Now, I want you to understand something. When I start talking about slopes of just a -3, we said the slope was what value again?
y2 minus y1.
Okay, formula-wise, but what was the value we got? -3. You've got to understand definition of slopes. Slope is always a rise over a what? Run. Okay, so when I say it's a slope is a rise over a run would imply a fraction form. When I'm looking for a value, it's okay to leave it as a whole number here, but you need to understand that in rise over run form, -3 is also equivalent to -3 divided by what value if there's nothing in the denominator? Not 0, but 1. Watch this. Watch what happens here. I'm going to go down 3 units and then over 1 every time. Rise -3, run 1. If I go down 3 and over 1, doesn't that put me right there?
Yeah.
If I go down another 3 and over 1, doesn't that put me right back there again?
Yeah.
See how that works?
Yeah.
Down 3 over 1. Then down 3 over 1 again hits that point, the 2 points we're talking about. Okay? So you see how I use this -6 divided by 2 to get -3, and then we just keep going down 3 over 1, down 3 over 1, graph our points like that.
Yes.
Okay. Make sense?
Genius.
Makes sense?
Yeah.
Okay. So you guys have that formula right there. And I guess what I would tell you to do here then quickly is this. Understanding that, hey, this gets you the same thing, what we just confirmed graphically. I guess what I'd like you to do here is this. On your own at the top of the 3rd page, try that formula out for these 2 points. Okay? Again, call this your first point. Call this your second point. First point. Second point. Whoops. Use that formula to come up with a slope. Okay, so I'm going to give you a couple minutes to try that. You get stuck, check with a neighbor around you. Again, if you disagree about stuff, what are you supposed to do?
Discussion.
Argue, right? Argue nicely, constructively. Okay, don't be hitting people with rulers when you argue. Maddie, did you hear that? So again, use those points up there in that formula.
This just means your second point and your first point. So this is my first point and second point.
Okay. Ready for
This
discussion?
slope's gonna equal, well, y2 is this one, right? It's gonna be
So we do
2
everything
minus
back
5. Do you see how I got that?
8.3.
Over x2, which is this one, minus that one.
I'm sorry.
That makes
And we
sense.
do everything on practice.
Do you follow that?
8.3, all the questions.
Okay,
Um,
so then like, so you can do that work, and then this one the same way, n equals. Cause this is
Is
like
it basically what, like, I can use my notes for what we
y1,
did last week? And
this
then-
is my x2,
Alright, and that's the only thing I missed, right? Just the quick quiz and this?
so like
Alright,
y,
everything in you. I have everything else in you that I did, I made except like one worksheet, right?
right.
And I have like 2 columns left. I'll get that done and have that handed in to you tomorrow.
Okay.
there.
Sounds
See
good.
if you could
Can I go get a drink really quick?
complete those then, okay?
That would make sense. I was like, I have enough time.
It has to be on a Friday because. No.
I'm pretty sure. Yeah, I'm pretty sure it's on that. So it'd be the 25th.
Yeah, when you get done, check with a neighbor, okay?
My neighbor Linda.
Yeah, that's crazy. He is so good at or Shaq. Can't remember his actual name. Called Shaq. He's 7'1" and really big.
I watch basketball.
I know who you're talking about. Okay, but he was on the League Girls, and they have a hard post today. Look at one of them. Makes sense.
Oh my god. Oh my god.
It's not about stamina. It's not just who you are.
Okay, how about volunteer to go up and do my first one?
I will.
Go, Mason.
Yeah. Where's the thing?
There's one right here.
Right here?
This one's better, yep.
Oh my god.
Okay, Mason, talk me through this.
Oh god. Okay. So I put 2 minus 5 because you know that's y2.
Y2 minus Y1, I agree.
Yeah.
Okay.
And then you gotta put like this little dashy thing. And then you gotta do 3 over 7 because that's
3
x.
minus 7, right?
Yeah, 3 minus 7. Because that's x2 and x1.
Okay.
And then I got negative 3 over negative 4. That's a 4.
Real quickly, negative 3 over negative 4. Talk to me about negatives over negatives. Fractions are really division, right?
Yeah.
Okay. So if I have a negative over a negative, or negative divided by a negative, what's this going to become? Positive, isn't it? Okay, let me take over here quickly just to make sure.
Okay, 'cause
Write down then, this is really equal to what over what then? Go, Mason, right equals what then behind
Wait,
that?
isn't 3 minus 7 negative 4?
equals.
Yeah, it's a negative 4 in the denominator.
Yeah, that's negative
Oh,
4.
okay.
Okay, so it's really equal to positive 3 over 4, right?
Yeah.
Okay, very good. Now one thing I would encourage you guys is this. It looks like we ended up with a positive slope, right? So if this is right, is my graph going to be some kind of an uphill graph or downhill graph?
Uphill.
It's going to be uphill. So I always like to go into decimals and just plug my points in again quickly. So I'm going to clear these out. Actually, I'll just go in here and change it. What was the first point, Mason,
Oh,
on your notes?
3.
3 comma what?
0, I think.
3 comma 2.
3
Comma
comma
2,
2.
yeah.
What was the second point?
7 comma 5.
7 comma
You
5.
go, Miss Miller.
Okay, check it out. Those are the 2 points that get plotted in decimals. If I work left to right, am I uphill or downhill? What's that imply about my slope then? Positive or negative?
Positive.
Has to be positive. So when I get done right here, I want to look at my answer right here. Are we positive right there?
Yeah.
Okay. Someone different for the second one, please.
Can I
Second one may be a
choose?
little more difficult. I don't care. I know who you're going to choose.
Who?
Courtney.
I bet she's mad about she's.
I don't have mine done.
Oh my god, you two.
TD, you got it?
Yes, I do.
Confident?
Yep.
Okay. Knock it out of the park, kiddo.
Alright. Are you recording this?
I am.
Oh, so I have to be loud?
You have to be loud and proud.
Okay. So, we do 2, because it's the first Y, or second Y,
Second line.
Yeah.
That's okay.
and then 4, because it's the second Y.
2 minus 4. Why 2 minus Y1 is what she said.
Fine, I'll yell.
Yeah. Yell.
Okay.
Get it all out.
And then 6, because it's the first X,
Okay.
and then negative 2.
Yeah,
because
very
it's the
good.
second.
Guys, one thing I want to point out too, and Taryn nailed this perfectly today. Anytime you substitute a negative number, you might always want to put what around that negative number? Parentheses. I think that that's a great tactic right there. Okay, I'm listening, Taryn. You're on a roll.
Okay, and it equals negative 2 over 8.
Okay.
But I think you can simplify, but I forgot to. So,
Okay. So first of all, is this going to be uphill or downhill?
down.
Okay. It is going to be negative. What's 2 over 8 going to simplify to? You know this. What's going to go into 2 and 8?
1/4.
Okay. So what's final solution going to look like here?
Negative 1 over 4?
Negative 1 over 4. Very good. Okay.
I was going to say that, but I was
Okay,
sure.
guys, I guess the last thing I want to hit here then today, thank you, Taryn, that was great.
Good job, Saran.
Finding slopes of given lines. Now, if you've noticed, one thing I'm going to point out is this. I'm going to put a line up here, and you can just kind of sketch a line somewhere. Watch what I do here. I'm going to put a line in here that looks like so. I'm going to say maybe it goes like this, all right? And on my graph, what I might choose to do is to say, okay, I got to find the slope of a line that they give us. That might be my line. Now, you don't even have to draw. Just pay attention to it. Did I give you any specific points to go from? No. This is the part that you're going to have to say, okay, here's my graph. What I need to be able to do is go in and say, all right, I need to come in here and look at my graph. Would you guys agree that maybe where I have my pen at right there, looks like it might cross the corner of a box?
Yeah.
Okay, so I might choose that point right there. Okay? You guys see that?
Yeah.
And then I might also choose, oh, how about right, does that look like one?
Yeah.
See it? So if they give you a line with no points, your job is to do what?
Look and see where I want.
Look at the points and then choose. So it looks like to me when I do this one here, and I'm not going to go over this too much, you're going to have to find corners. You're going to have to find corners of the boxes in the coordinate plane where the line passes through, clearly a corner of those boxes, and pick them. It looks like to me I go down 2 and over. It looks like 1, 2, 3, 4. It looks like 5 to me. Okay, would you guys agree with that?
Yeah.
So down 2 and over 5 looks like negative 2/5 there. So if they ever give you a line and say, hey, find a slope, but they don't identify any points in it for you, you have to pick a couple points where it passes through the corner of one of the boxes in the coordinate plane. Make sense? Okay, by the way, would that be positive or negative there?
Negative.
Negative. Okay, so, what's that?
Down.
Oh, yeah.
Is it uphill or downhill? Left or right?
Yeah, I see.
Okay. All right, so I guess the last page what I'd like to do is kind of come together here and talk about what's going on. Things to remember. What's slope again?
Rise over run.
Okay, so let's just kind of summarize all this here today. Slope is a
Rise.
rise over a what? Okay. If you have anything that has a positive slope, is that an uphill graph or a downhill graph?
Up.
So you might want to jot that in there. It's an uphill graph, right? How about negative slope, uphill or downhill?
Down.
What do we say about zero slope?
Straight.
Horizontal, isn't it?
Yeah.
Left to right. Is there any uphill or downhill to it?
Nope.
Okay, now the one thing that we didn't talk about was an undefined slope. Okay, we have things that go up and down. We have stuff that goes left to right, but an undefined slope would be something like you're Evel Knievel and you're going to ski this slope. Okay, undefined slope is going to be a vertical line. So think of the coordinate plane, the XY axis together. Can you guys think of that right now? Which axis has a zero slope?
Y. No, X.
The x-axis, the left and right one, right? Which axis has an undefined slope?
Y.
The y-axis.
Like the water slide at the water park up
Yeah.
in Waterloo.
Yep.
I go on that. I at least get water in there.
Okay, questions about this at all? All right, attached